Thank you very much. Thank you very much for inviting me here. In 1969, we made an important scientific discovery, the discovery of spaceship Earth. Steve quipped that we traveled to the moon, but what we did there was to discover the Earth. Of course, we knew the Earth existed. That's just a joke, of course, but what did we really discover when we went to the moon? Really was the Earth, and what did we find? What we found was that we existed in the vastness of space, surrounded by the vacuum. It was very cold, and all of life existed on a little thin shell around the Earth. And so we, ever since then, have been taking regular imagery of the Earth, and this has helped us to understand it. But at Planet, what we have tried to do is take it not just from awareness of the planet to being able to help to take care of it by taking action. So moving from awareness to action in a way. So in this video, I'll just go back one, if I can. Let's see if I can do that. No, that's the wrong way. Oh. This is, we decided to launch a constellation of satellites that would image the entire Earth's surface once per day, to track changes on this beautiful spaceship Earth. And because we've got to take care of spaceship Earth and the 7 billion astronauts that we have on board it, as well as all of the rest of the ecosystems that are on there. And it stands to reason that if you don't have information on a timescale of human action, that you can't do anything about taking care of our spaceship. In fact, when we design spaceships to go into the Earth orbit, we of course think very carefully about the spin rates and the other things that are affecting the spacecraft, and we have to take measurements of those spacecraft faster than the time scale that they spin in order to do anything about it. And the same is the case for our Earth, and human activities on it take place on hours, days, and weeks, and so we needed data on that sort of time scale. So this is how our constellation works. We have launched a couple of hundred of satellites. It's the largest number of satellites ever put into space. And they orbit the Earth in a polar orbit, a sun-synchronous orbit. And each one takes a strip of images as it goes around. And we've launched, we have over 100 in one orbital ring, which literally end up scanning the entire Earth every 24 hours. We also have a fleet of, and they do so at 3-meter resolution. We also have a fleet of 13 higher resolution satellites that can zoom in and take more close-up imagery where we find things that have changed on the Earth's surface. And they have 70-centimeter resolution on the Earth's surface, and they can also take video. So just moving on, if I can move to the next slide. Oh, I've gone backwards. Let me try and go forwards this time. So we're in a space renaissance right now. Just to give you a little bit of perspective, last year, we launched just over 150 satellites. In all the previous years of space history, about 100 satellites have been launched from the whole world, from all the different space agencies, all the different companies, everyone else. And the satellites themselves cost less than 1/100th of the lowest cost satellites prior to them. So a dramatic reduction in the cost of the satellites enables you to launch many more of them. And launching many more of them enables us to have this faster cadence imagery. So let's look at why this renaissance is happening. It's primarily because of the consumer electronics and the billions of dollars that are going into consumer electronics miniaturizing capabilities, mainly in our smartphones and in our laptops. So in these things, we have incredibly powerful computers, sensors, cameras, radio systems, hard drives, incredible what has been packed into these little devices. And what we did at Planet was more or less take and leverage that capability and put it into space. We call it strapping space to Moore's law. Historically, the space sector had very much driven the development of its own technology, and now we were trying to take that and just utilize it rather than doing the other way around. What is also very significant is in the last few years, the development of artificial intelligence and machine learning has enabled a vast array of ways of interpreting the data that didn't require lots of human touch. And that enables us to process the millions of images that we now get down from space each day. Our satellites are very small. They weigh about 4 kilograms. This is then compared with a Landsat satellite, in which the cost differential is not hundreds, it's tens of thousands. We've done multiple iterations of our satellites to keep it up to date with Moore's law. And we've launched them on 21 rockets. We have another one, 2 rockets launching next week, so we 23 next week. And all of that provides imagery of 350 million square kilometers, and the land area of the Earth is 150 million square kilometers. So we cover some of the oceans, the Arctic regions. We have 31 ground stations all around the world. We download rather a lot of images each day. And this is just a video of one of the launches where we launched 88 satellites in one rocket, which broke our previous record, which broke our previous record, which broke our previous record, which broke the Russian record of 14 satellites prior to Planet. Those little things coming out the back, they then orientate themselves and go around the Earth's surface. So this is what our satellite fleet now consists of. Actually, the first 5 satellites were built by Surrey Satellites that Martin spoke about prior. We have then the Dove satellites, as well as the 13 higher resolution SKYSAT fleet. This is what the imagery looks like. That's a full frame image. So you can see a ship, a vehicle on the road, but you can't really see a person or read a number plate or anything like that. This is a full resolution of that imagery. But we see that image of the entire Earth's surface each day. And this is one of the SKYSAT higher resolution imagery. We cannot take the whole Earth each day, but here we could take the major urban areas each day. Again, now we not just see a plane, but tell which sort of plane, count the crates on a ship or various other details. And now we have, on average, over 800 images for each location on the Earth's surface, roughly the same number of images as were taken for the entire history of Earth in all the history of the space age prior to that. And so that documents immense change around the planet. But I wanted to really get to, and this is what it looks like in Los Angeles port, just to give you a sense of all those changes. But I really wanted to talk about some of the applications. So we set ourselves the goal of imaging the entire Earth every single day and making that change visible and accessible. And we achieved this goal last year, so about this time last year. So now the Earth has been imaged every single day for a year, and we'll continue to do that. And we keep all the data. We don't throw any of the data away, so we always have that historical record. But now what is the next challenge? The next challenge, the next thing we are setting ourselves as the vision, is to index everything on that Earth by applying machine learning. So if in each picture, the same algorithms that Google has developed and others have developed to detect cats and dogs in videos and pictures that you post online, can now also be applied to doing something I consider slightly more useful, which is figuring out what's on the Earth. And so you can do that to find, hey, this is a ship, this is a tree, this is a car, this is a road, this is a train, this is a plane, and then you can essentially index everything on the Earth. So Google itself had set itself the goal of basically looking at the web and indexing it so that you could then search it, right? And we are doing something similar with the Earth. indexing what's on all of the Earth's surface each day, and then you could search it. You could say, hey, how many houses are there in Pakistan? Give me a plot of that versus time. Where are the number of floods in Indonesia this year? Or how does that compare with last year? Or just tell me the latitude and longitude of the trees that went down between this month and last month in the Amazon. Just tell me where they are so that we can go and send people to stop those illegal logging activities. Instead of getting millions of pictures, you just get answers. I'm going backwards. So let's talk about some of the applications. I'm really going backwards here. So this is just a little bit about the machine learning. So basically, this is an example of how we can detect ships' imports, and the machine learning automatically finds the ships, and not only finds the ships, it will just give you the list of the ships and their location in that area back through time. And you can filter the number of ships. It will just tell you the latitude and longitude of the ships, the size of the ships, their heading, and things like this. And it will automatically do that across the entire Earth's surface. Some of the applications, this is really what I wanted to focus on. So there's a lot of security applications. There's a lot of agricultural applications. So and this is mainly talking about some of the commercial applications of this data. Our biggest market is actually selling to agriculture, because 26% of the land area of the Earth is agricultural land, and we can use it to improve crop yield in farms, because we can tell crop type and crop yield from orbit using a particular spectral band. And we can do that for all the agricultural fields in the whole world each day, and help each farmer to decide when to add fertilizer, when to add water, and so forth. In forestry, the application is fairly obvious. It's helping us to track and stop deforestation. In the oceans, it's the same. So it's helping us to track and stop illegal fishing. There's many other commercial applications, but I wanted to talk a little bit today about the applications to do with Sustainable Development Goals. Because the Pope actually gave a really interesting encyclical in 2015, all focused on caring for our common Earth. And of course, that's the whole focus here. And we're not doing this just as an academic exercise. The point is to help real people on the ground, and in particular, the poor people that are affected most by climate change. And so we did an assessment of how our data can help the Sustainable Development Goals. I'm going to skip through these. But this just shows you just some of the dramatic deforestation that goes on in the Amazon on a regular basis. This is over the course of a year. And just from an environmental standpoint, we recently did a project where we're now mapping all the coral reefs each day and tracking to see if there's any illegal ships, or if there's bleaching, whether there's anything we can do about that bleaching by quickly reacting in the cases where corals are bleached. But the first time, all the corals have been mapped on a regular basis. And this was actually just two or three days ago in California, tracking the fires. Disaster response is a big application area of satellite imagery, as Martin had already noted. And this is more on that. But I want to talk about the Sustainable Development Goals. We assessed that 12 of the 17 Sustainable Development Goals could be significantly helped by more regular satellite imagery of the Earth. Again, not just to help us to understand that climate change is happening, but to actually take action. So I'm just going to go and give a few examples of this. So in the first one, to do with poverty. A lot of poverty relates to refugees as well as to disasters. So this is we have actually a series of daily images, but this just gives you a quick snapshot of the build-up of a refugee camp. And by helping everyone to know how many people are there, by assessing the number of tents and so forth, you can help relief efforts going into these refugee camps. In the area of zero hunger, I already mentioned how we can look at crop yield in each farm around the world each day. Of course, that can be applied in developing countries as well as developed countries, so it can be not just for commercial uses, but also humanitarian ones, and we can help predict crop yield, and therefore the big ag companies are interested in that, but we can help the poorer farmers to determine when to add fertilizer and water and so forth to improve their crop yield, and therefore reduce hunger and malnutrition. On clean water, this is an image just of a reservoir, and we will see it change over time. So I'm just going to go back and forth. There you can see those two, just as over the course of a month or so, that reservoir change. We can tell the reservoir levels of every single reservoir in the whole Earth every single day and help people to manage that important resource as water becomes one of the most scarce resources around the planet. Of course, climate action, measuring key climate variables is one of the most important things that we can do with the satellites. In this case, just looking at glacial changes. This, again, let me just snap between these two. This is just over the course, just a change over the course of a couple of months. And then also related to climate action, I already mentioned tracking deforestation. This is just over the course of a few months here, the tragic loss of forest here. But the most important thing is not just being able to identify a tree when it goes down, but also assess the carbon stock, which we can also do automatically with our analytics tools. So I think the key thing here is, and then I'll wrap up, that we're going from a situation of having data that helped us to understand how the planet was changing and evolving on a relatively long time scale, to being able to have data to help us to take smarter decision making on a day-to-day basis. And it's with that kind of information that I really believe, it's obviously not a silver bullet of information, but it is a significant thing that can help us at a global level to measure and respond and address the Sustainable Development Goals, and therefore get towards the Pope's vision of caring for our common Earth, and help some of the biggest challenges around the world. I would just leave you with one quote that I wanted to quote from the US ambassador to the United Nations in 1957, coined the term of the spaceship Earth, and I really love this. And he says, "We travel together, passengers on a little spaceship, dependent on its vulnerable reserves of air and soil, all committed for our safety to its security and peace, preserved from annihilation only by the care, the work, and I will say, the love we give our fragile craft." And I think that captures where we are at. Humans are dramatically changing the Earth, and we need not just to understand how we're changing the Earth, but to take action on a very quick basis and to course correct human activity. And for that, we need data that is regular of our planet, and this is what we're trying to help within Planet. And so with that, thank you very, very much.
Thank you, Martin and Will. I think we should have a few questions on these two papers before we move on to things far beyond the Earth. So, yeah.